Hi, I'm Dr. Incognito. In this video, we're going to take a look at some more examples of the chain rule. So the chain rule is used for finding the derivative of a composition, f of g of x. G of x is inside of f of x. And the rule is the derivative of a composition is the derivative of the outside times the derivative of the inside. When you take the derivative of the outside, you leave the inside in. So we have f prime of g of x. That's the derivative of the outside, leaving the inside in. And then times the derivative of the inside, g prime of x. Let's have a look at this example. We want the derivative of x cubed times the cosine of 1 minus x squared. So the chain rule is going to be involved in this problem, but there's something else first. The function we want the derivative of is clearly a composition. It's x cubed, that's one function, times the cosine of 1 minus x squared. This is another function. So we have two functions multiplied together. The second function appears to be a composition. Cosine of 1 minus x squared is a composition. 1 minus x squared is inside of the cosine function. But before we get to that, we have to deal with the fact, the larger picture, this entire function is a product. So we're going to begin by using the product rule. The derivative of this is the first, which is x cubed, times the derivative of the second, which is going to require a chain rule, plus the second, the cosine of 1 minus x squared, times the derivative of the first. That was an easy derivative, but I'll hold off until the next step. This is the form of step one. The first function times the derivative of the second function, plus the second function times the derivative of the first. And it's at this point that we need to use the chain rule. At this point, I want the derivative of the cosine of 1 minus x squared. So I use the chain rule, the derivative of the outside times the derivative of the inside. So we have here x cubed times the derivative of cosine of 1 minus x squared is going to be negative sine of 1 minus x squared times negative 2x. The derivative of the outside function cosine is negative sine, leave the inside in, and then times the derivative of the inside is negative 2x. And then here we have the outside function, the second function times the derivative of the first. This derivative is 3x squared. I'll put it in the front. 3x squared cosine of the angle 1 minus x squared. And we can clean this answer up a little bit. The negative, there's a double negative, they're multiplied together, that's positive. And then we have 2x times x cubed is going to give us 2x to the fourth, and then sine of 1 minus x squared. So that's a little nicer than this. And then plus, just copy the other one, 3x squared cosine of 1 minus x squared. Okay, let's look at another example. So this example involved a chain rule within a product rule. Let's look at an example that involves a chain rule, a composition within a composition. So let's take the derivative of secant to the fourth power of x cubed plus 1. So this is not an ordinary composition. This is not a basic composition. This is a composition of three functions. The x cubed plus 1 function is inside of the secant function, which in turn is inside of the fourth power function. So it's not quite f of g of x, it's actually f of g of h of x, 3 layers. And the way we can untangle this using the chain rule is to use it twice in a row. The outermost function is the fourth power function. And then what's inside of that is the secant of x cubed plus 1. So let's just think of it on those terms. There's an outside function, which is the fourth power, and the inside function, which itself is complicated, but it's the function secant of x cubed plus 1. So if I do the derivative of the outside function, that would be the fourth power. I get 4x cubed, but I don't want to say x, I want to leave the inside in. The inside is secant of x cubed plus 1. So I want to do 4 times this cubed. And then times the derivative of the inside, the g prime of x. But instead of just writing out what that is, it's a little bit complicated, so I'll indicate it for the next step. So the derivative of the outside. So I take the outermost function, which was the fourth power. I take the derivative of that. And then I have the derivative of whatever was inside of that, which happened to be a composition. So now we use the chain rule again on the derivative of the inside. So we just peel off one layer at a time. I peeled off the outer layer here, and now we're going to do the chain rule on this one. So 4 secant cubed x cubed plus 1 times. The outside function is the secant function. The derivative of secant x would be secant x times tangent x. So what I want is secant of g of x times tangent of g of x. That's the derivative of the secant, the outside function, leaving the inside in. So the derivative of secant is secant times tangent, and I want to leave the inside function in the derivative, so secant g of x, tangent g of x. And then times the derivative, so we've peeled off the secant layer, and then finally we have times the derivative of x cubed plus 1, times the derivative of the inside. Now this one I could have just written 3x squared right away, but I'm just trying to indicate here that when you have multiple layers, then you're just peeling off one layer at a time. First the derivative of the fourth power function, and then the derivative of the secant function, and now finally the derivative of the x cubed function. So the final answer, before maybe making it look nice, if there's some, there might be something we can do to make it look nice. Just copying all of this, and then times the derivative of x cubed plus 1 is 3x squared. The numerical coefficient of the whole answer is 12. I have 4 times 3 is 12. I have an x squared also. So we have 12x squared. And then we have secant cubed times secant. That's secant to the fourth. And then times tangent of x cubed plus 1. So there's the final answer, all cleaned up. Okay, so there's a look at a couple of examples of the chain rule in action. One where it's the chain rule within the product rule, and here where it's the chain rule within the chain rule, a composition of 3 functions. Okay, thank you for watching.